Okay, so you just watched a video showing a second strategy for how to find a sample space. So the first video showed making a tree diagram. The second video showed making a list, which I have here. This is what we talked about in that second video. So what I'm going to show you is a third strategy where you don't actually get to see every single outcome, but you can quickly figure out how many total outcomes there are. Let me show you how to do this. Looking at this example we have on the screen where we rolled a dice the first time and you got a 1, 2, 3, 4, 5, or 6. And then we rolled a dice the second time and got a 1, 2, 3, 4, 5, or 6. When we counted every single possible outcome, we got a total of 36 possible outcomes. We did that by listing all of the possibilities. A faster way would have been our first roll, we had 6 possibilities. Our second roll, we also had 6 possibilities. If I just multiply those two together, I find that my total is 36 possible outcomes. Okay, let me show you with heads or tails. Let's say I wanted to, in fact, I can go back to this. Let's say I wanted to flip my coin one time. Well, there's only 2 possibilities, heads or tails. But what if I want to flip it a second time? There are again 2 possibilities, heads or tails, right? And what if I want to flip it a third time? There are still, right? It's still the same coin. I still only have 2 possibilities, heads or tails. If I multiply those all together, 2 times 2 times 2 equals 8. And if I look here if I flip it 3 times, there were a total of 8 possible outcomes. So a faster way to find just that number for the total sample space is you can multiply how many possibilities do you have the first time times how many possibilities do you have the second time times how many possibilities do you have the third time. Now you have to be careful. For these 2 examples I've just shown you, you always are multiplying the same number, 2 times 2 times 2, or 6 times 6, because the dice didn't change or the coin didn't change. But what if I have 5 pieces of paper? Well, and I want to draw a name out of a hat. I have 5 names on paper. My first time I draw a name, there are 5 names in the hat, so I could draw my name. But I'm going to keep that name out. I'm not putting it back in the hat. I want to draw another name. Well, this time I don't have 5 names in my hat anymore because I took one out. So I only have 4 names this time. So if I wanted to draw 2 names, I could have first drawn any of those first 5 names. Then the second time, I could have drawn only any of those 4 names. It would have given me a total of 20 possible different outcomes. I'm not saying I could draw 20 names. Obviously, there's only 5 names. But there's 20 different combinations of names that we could draw.